our program, and we will introduce some new concepts too. So if you were working at a development shop, right, and then they'd be like, okay, so what's next on our tab? They're like, well, we need to mimic a real ATM, right? So that means this has to go, like this parameter has to go, because the way we have the code structured, anytime we want to work with a excuse me, different customer, we have to create a new ATM, meaning restart the program, restart the ATM, and that's not good, right? so that has to go away, and maybe we do that, and then it has no parameters. Okay, so we change that to this. We are not going to be working with one bank account. What we will do is we will simulate a list of customers, and we will simulate with a list, with a vector. So we will create a vector of bank account objects, accounts. And part of the discussion today revolves or focuses on private functions. So we will get a demonstration on public functions, although you've already done public functions in your homework, but I'll still cover it here, right? So we will create a get balance from DB function, and this function will use the C++ random operator to generate some value from 1 to 10,000. And when we create a bank account instance here, we'll call the get balance from DB, get some number between 1 and 1,000, and the bank account instance will have whatever number is chosen. Okay, and what else? Then we will also simulate with a void. We'll simulate scanning a card. So we'll say scan card. Obviously, we don't have hardware. So what we will do is when that is called, we'll also use a random generator. We're going to have a vector of bank accounts. 1, 2, 3, 4. So the index is 0, 1, 2, 3, 4. So scan card will generate a number from 0 to 4, and this will be like account 1, account 2, account 3, account 4, account 5, and we will be simulating that they type in their password, but we're not going to ask for password, right? We'll just say scan card, and then the random generator is going to give us a value, and we will use one of these values here to get an object from the accounts, and we will be using that object to display the balance. Okay, that way we more or less get a real world feeling of how we can build an application. Okay. Okay, so let's go ahead and make the changes. I have to change source code. So this is the other classes, so I don't want to save this. I'll close folder, and I'll open this one. So while that's opening, we will also be introduced to a friend of a class and with a class, right? So last time we said friend of a class with a free function. This time we'll say, oh, a class can also be a friend of a class. We'll talk about the explicit constructor, what that does, and then we will talk about operator overload. And if you saw the weekend review, then you know what I'm talking about, right? We want to shoot toward having C++ recognize our user-defined types as almost C++ types, fundamental types, right? Like as if they came with the core and standard library. Okay, so let me see, we go to ETM. First change is we need to not accept the parameter, and we will write some code in the CPP for the constructor, and we eliminate the bank account reference. We need to include vector, and then we say, okay, create a vector of bank account, and we will name it accounts. Okay, this function stays the same. Okay, so let's go ahead and go to the CPP, and we will write code for the constructor. Notice the difference between the constructor and the function, right? The function has a return value. The constructor does not have a return value. Just like over here, we don't have a return value, okay? And notice right away, we get an issue with account not defined. Well, it's not defined because we removed it, but we'll fix that in a little bit. Okay, so here we need to create bank account instances. However, we need to mimic or simulate getting values from the database. So we will say get balance from DB. Okay, get balance from DB. Let me find my repository here. Okay, so we go here, and we need to add another function, and this will be private. So we say void get balance from DB. Obviously, we don't have a database, but we will simulate. In a real world scenario, we would probably have another class. We will have another class that would know how to communicate with the database and accept the customer ID, perform a query, and then give us the balance for that account. Okay, but we're not going to do that here. Instead, we will simulate that. Also, another issue I saw in the tic-tac-toe application, sometimes students wouldn't prefix the function name with the class name. So if you do this, this is a free function. You want to make it a class function, you have to prefix it with the class name followed by a double colon, okay? Okay, so we return rand. We need an include, but for now we'll say 10,000, and let me see the example here, plus 1, okay. And we have to include, what's that guy? stdlib, I think. stdlib header, yeah. Okay, so once we do that, then it should be happy with us, hopefully. And then we can call this function stdlib header. Come on, catch up. Examples, build. And still no likey.
It looks like it's complaining that you're returning something, but it's a void function.
Well, actually, it's right. I should be returning something, right? Okay, there we go. And let's build it. Okay, that's fine. Actually, let's go here to this one. That one doesn't include main. Okay, so this one builds main, and this one does not build main. The lib. Okay, so obviously it's erroring out because main is expecting ATM to have a constructor argument, but we removed it, so we'll go back and fix it in a little bit. Okay, so we have that part. Now we can come in here in the constructor, which runs one time when we create the instance of the class, and say accounts dot pushback a bank account instance, and then we call get balance from DB to get some number. Okay, very simple way just to simulate. And then we add 5 of those. So 1, 2, 3, 4, 5 bank account instances will be added to the accounts vector. And remember, a vector is a list. Okay, so we go and now we have to implement scan card. And scan card will be updating this customer index value, and that index will store a value from 0 to 4. So we can go here and write the code here, ATM, and then we say customer index equals rand, what's that, rand accounts dot size minus 1. I shouldn't do, well, these guys are canceling each other out, right? So I guess I don't really need them, but oh well, I'll leave it like that. TM accounts the mod sign. Okay, so now when we call scan card in main, it'll just generate a number from 0 to 4, set it to the index, and if we go here, now we can call display balance, right? So we'll go the long way. We'll say, okay, bank account equal accounts, that's the list, right? That's this vector right here. It's a list of accounts. So we'll say give me the item at customer index. And maybe just to be safe, we should probably initialize this guy to 0, right? Just in case somebody tries to call get balance before calling scan card, but oh well, we're not gonna worry about that here. Okay, so any questions so far with what we are doing? So we go back to the UML. We've modified the constructor. We've added the scan card functionality. We've added the list of accounts or the vector of accounts. And we've added this get balance from DB function. Okay, so go back into main, and main is complaining because ATM does not take an object. So for now, we don't need this, and we don't need all of this. Okay, we just work with ATM, and notice how our main is like super small, right? And we don't need this parentheses. Okay, so what happens here? Line 10 executes, ATM, compiler finds that we don't have a parameter. It's like, oh, this constructor, and then it creates a vector of 5 bank accounts, getting the balance from this function, which generates a value from 1 to 10,000, just to get different balances for each account. So before we call display balance, maybe we say scan card here, and maybe what we should do is probably create a loop here. While choice equals yes or yes. and remove that one, semicolon, choice. I don't think we have cin over here, so we'll say using cin, and now we can say can type continue. Okay. And so we run the program and it should display different balances. Okay, so let's see what happens here. Running terminal. Okay, the first one had a balance of whatever, 9170, 1479, 9962, 4605, 293, 4772, 6300. Okay, so let's see, what do we do? Is it me or am I seeing more than 5 balances? Let me run it again. 1479, 9962, 4605, 293. That's 1, 2, 3, 4, 5 different ones, right? 4772. 6300. So what happened? Oh, that's on me, right? Because I'm creating the ATM machine again each time. Okay. That's why we're getting weird numbers. Okay. So now let's run it. Yes. 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 Okay, that's more like it, right? Anyways, okay, so questions here? Any questions? Pretty cool stuff, right? That's why I like object-oriented programming. Like, you can create objects and then they interact with each other, and you can create pretty cool stuff. I mean, you can with functions too, free functions, but I just like this programming methodology a lot. So no questions. Okay, let me do something here. So let me run the program again and stop it. No, let me. Okay, and let me display more of the screen. $91.70, 6501, 6501, 6335, 6335, 91.70, 6335. So is it really generating random values? Let's run it one more time. 9170 is again 65. Okay, again. So it's not really generating random values, right? Let me find the fix for that. It's in my repository for last semester because I don't have it memorized, but we can get to it. Here it is. We have to make one minor change in main, and we have to call the time function, I think. Where's my main here? Yeah, okay. So you saw the issue that we're having, right? Like it generates random numbers, but every time we run the program, it generates the same random numbers, which is probably not what we would want, right? If we were creating an application that depended on random numbers. So we include time.h. Also, I noticed that some students were putting a semicolon at the end of include statements. Don't do that, right? Like you don't need semicolons at the end of include statements. Okay, so then here in main we can say srand and then time null, and this function should allow us to generate truly random values, right? So let's see, run in terminal. Okay, let's let a few seconds go by, right? Or milliseconds. And then let's see what happens, right? So now, okay, let's see, 1001, 1002, 1003, that should be enough time for the computer. And now, notice now, we do get better randomization, right? So, so remember this, because for the final exam, you roll some die, and you simulate the game of craps. So you need the randomizer, okay? So to generate truly random numbers, you need the srand time function call, and then you need the rand. So those combined together generate truly random numbers, right? So this creates a randomizer seed number, and then the algorithm uses that number to generate different numbers, okay? Questions? Okay, so seems that there's no questions. Okay, so now let's talk about friends of classes that are classes themselves, right? So we'll have a friend class friend, I guess, and that class with one of its functions can reach into its friend class and access private data. Okay, so let me go here. So you'll be able to access either balance or bank balance, okay? And for this example, we have to create another class, okay? Also, please, for the tic-tac-toe application starting, I guess not this week, the following week, do not forget to follow the instructions to add these guys. I mean, if you want, you can add them in this next assignment. If not defined, bank account underscore h, define bank account h, and then this guy at the end, right, in div. That helps when you are working with more than one class. Okay, so you won't get that class is already defined issue. And if you do, then remember it's like, oh, the header guards, I need to add them. Okay, so what I'll do here is I have to create another class. I'll create it in this same file because I don't have another file free. So I'll say if not defined branch bank header, then define branch back header, and diff. And this is a very simple class. It's a branch bank class. Open, close curly brace, semicolon. It'll have a branch balance. And should we initialize it? No, we initialize it with a constructor. So branch bank, and when this executes, then branch balance, get the value of the incoming parameter B, open close parenthesis, curly brace for the empty code block. Okay, this one should be under public scope. And then we have a function that's void update balance, and we'll accept some value B. And what do we do with that one? Pretty sure we have to update that one and maybe one of these two values. Okay, but let me verify my example. I don't have the examples memorized, sorry. But I have a guide here. If I can find it. Update balance, yep, okay. So we go to branch account CPP. I scroll all the way to the bottom. And okay, so then we say, let's write some code for this guy. It belongs to the branch bank class. And what do we do? Very simple example. We will simply update the branch balance with whatever value that is. The important concept here is to show you the friend functionality, okay? So we're not validating for valid data. But also we can say a bank account, bank balance plus equal B. But notice it's mad at us because, well, we're not friends yet, but we will make them friends. Okay, so we've written the code for the class. So now let's go into the bank account class and give permission to this branch bank class. So let me see, where is friend? Right here, header. And then we say, okay, friend class void. Notice we have to use the branch bank prefix, and then we can say update balance. So meaning this function from update balance that belongs to branch bank is my friend. Okay, and then we say, okay, integer B. So now we can go back over here and notice now it's okay. It'll allow us to modify the bank balance just with this statement right here. Okay, and then we can go into main and how do we do it here? ATM for now. We're gonna mute you. Oops, all the way here. So we create a bank account. Okay, $100, and then let's say account see out. Maybe I should just say display balance, right? Display balance. Let's create a branch bank class. So branch, some begin value, I don't know, 100,000. And then let's say branch update balance. Let's set, I don't know, 5,000. and let's call cout branch balance branch dot. We can't get that guy. I guess I need another function, right? Get branch balance. Okay, so let me go up here, and we need integer get branch bank balance const. We don't want anyone to modify the balance, and then we simply say return branch balance. Okay, so branch balance is here, so we are returning this value. Okay, so then what do I do here? Make it easy on myself, right? Just do that. Okay, so what are we doing here? We create an instance of bank account, begin value 100, we display the balance. We create an instance of branch bank with begin balance of 100K. We add 5K, and then we will look at the balance, and then we'll see if it affects this guy's balance too. Okay, I think that's what I was thinking back then. Okay, so let's see what I've done. Run in terminal. Any questions? Okay, so what happened here? My mistake. That's why you shouldn't rely on functions, right? Bank balance. We need to display the account.get bank balance, not the balance. Okay. And now let's run it. What's the whole purpose of this? Just to show you that a class can also have access or not, right? Let me see here. What am I running here? Okay, there we go. Right. So we added 5,000 to the branch bank, and then in here we're also trying to modify the bank balance value, which was 100 initially, and then we add 5,000 to it, so 5,100. Right. Probably not the best example accounting wise, but conceptual wise for C++, it shows that we can use a class function as a friend to modify another class's private data. Okay. yeah, they wanted it last week, but I didn't record, but they'll be fine. Okay, so again, accounting, this is not the class, right? It's just showing you that you can modify balances with a class function. Okay. Okay, so questions? Okay, let me do something here. So next topic is explicit, okay? So let me do this here. Thanks to the modern IDEs, or integrated development environment tools, we pretty much know if we're on the wrong path, because we always get slapped on the hand, right? If we've done something wrong. But notice here, like, this code says that the bank account is equal to 100. I mean, if we're paying attention, right, we're like, hey, wait a minute, this is a user-defined type bank account, but it's allowing me to apparently like use an integer to create a user-defined type. Okay, so what's happening? This statement executes, the compiler scans our constructors, and it's like, oh, there's a constructor with an integer. So I will use this statement and this constructor, like, oh, that's the compiler speaking, to create an instance of bank account. Probably not bad, but there are some development shops that they don't want that, right? They want, when they want to enforce creating an object either with a function or the way we've been creating them, right? Like this, and not like weird syntax like this. Again, probably not the worst thing in the world, but if we didn't want them, the book doesn't cover this, right? This is just like C++ stuff. We don't want them to do this, then we can say, well, you know, if somebody wants to create an instance of bank account, then I'm gonna make them or force them to use the constructor. This will not fly. Okay, so you see, no suitable constructor exists to convert from into bank account. And if we go and look at this, it's like convert constructor. So then without the explicit keyword, this is the convert constructor, allowing us to execute code like I just showed you to create an instance, but we don't want that. We want them to explicitly create objects. So then they can't do that. They can do this, or they can do this. That'll work just fine, but not this. But was that code really gonna work if we remove this? Well, let's try it, right? So let's go over here, and the error is gone. So usually if the error is gone, that's good news, right? So then we run in terminal. And notice it does create an instance of bank account with this integer 100, right? We don't want that. We want them to use constructors explicitly. So we will use the explicit keyword here. And then go back to the original code, which was that. And that should still work. Run in terminal. And it still works, right? So, okay. So, on to the next topic, which is operator overloading. Okay, so let's go look for cout. Well, first, let's look for branch. Branch is of type branch bank. Bank account. So account is of type bank account. Okay. What type is cout? Cout is of type ostream. So it's an ostream class. Okay. Where is cin? Well, let me just do cin here. What type is cin? Istream. So it's an istream class. Okay, so hence overload operator ostream, istream, and the plus sign. But what does that mean? Okay, so let me include string here. String. Create an instance of string name, assign it the value Joe, and then we can say cout name. Remember I told you string is a class, and we can use this code right here without any issues. Bank account is a class. Account is an instance of the class. Can we do cout account? No. Why? Because we've not written the code to allow C++ to use the cout or ostream class to work with our account type. And if we're able to do this, then we are closer to having C++ recognize our classes just like it does the string class, right? Meaning, oh, somebody probably wrote some code to make this work. Because, I mean, we are following the same things, like string is a class, bank account is a class, name is a type string, we can use cout, but not account, we can't use it. So that concept is known as operator overloading. We will give the cout or ostream class extra functionality, and that functionality will be to recognize our classes with cout and cin. Okay, and we use the concept of friends to do that. So we will use a friend type. Let me make sure I give you the right code, and when you see the code, you'll be like, oh, that's why he was looking at it. Class overload. Where are you? I think it's this one. Yeah, when you see the code, you'll be like, oh, okay, so now I know. I don't work with C++ every day, but I do study it a lot, right? Because I like it. Okay, so we go here, and we have two friends. Let's add another friend. And the friend will be friend stud ostream. And remember, cout is of type ostream, so we're saying we're adding extra functionality to the cout object. And then we say operator, and we will say, okay, what parameters? So we want to work with ostream, a reference, and we name it out, not cout, and that's only to differentiate between out and cout, okay? Because I'm sure by now you've noticed that if we include iostream and then stud cout or anything like that, then it knows that it's cout, but we don't want the compiler to confuse him, so that's why we name it out, okay? And then we work with a const bank account reference account. Okay, so let's go back over here. What's going to happen when we try it again? Oh, so now cout's like, oh, I know what to do with this guy. Well, almost, right? We haven't written the code for it, but we've written the friend header, friend function header. It's kind of like, okay, so what next? Okay, when cout is called and account is on the right side of the operators, we can pretty much understand that behind the scenes, C++ is like, oh, okay, so they have cout, and then, oh, okay, they have account, right? So from we can conclude that from here it calls, oops, this function here, and it'll execute it. So understanding that, then we can go in here and add code for it. So we are like, okay, friend free function. Okay, so here. And again, we do not need the friend keyword. So now we have the overload. And just to make sure that we understand what's going on, we, instead of saying cout, we say out. Why out? Out. And then we have to return ostream. What's ostream? This is ostream. So we have to return it. Just use that one. Okay, so out, account balance, right? So then here, instead of saying friend, we'll say overloaded ostream. That way, when we execute the code, we can know that, oh, okay, this function's executing, and that's what we've been doing, right? Just so that we can get a visual of what's going on. So again, notice we have access to the bank account's private data balance. Why? Because we've stated that it's a friend. Okay, so it's a friend of the bank account class. And this is a free function. Okay, it is not part of the class. We come back over here and we're like, okay, so no errors here, which is usually good for us. Let me do that. Okay, and let's go ahead and execute this code. Run in terminal. Overloaded Ostream display balance 100, right? So we've just given our class extra functionality via operator overloading, meaning now cout recognizes our bank account and it can display just like this, right? So instead of writing code like cout account get balance and displaying it, now we can just say, hey, cout account, and this code executes here, right? So that is, in the long run, fewer lines of code for us, right? Which is good. We have to make sure we return out, because we may have cascading output, right? So we have one and then another one. So that's why we have to return out and a reference of it. That's why it's the same cout executing those different statements after those operators, okay? So that's why we need to do that. Questions here? Let me go back over here.
Can you explain how that reference Ostream parameter, it makes it into the function that returns the Ostream? Like, is it implicitly included somehow?
Well, I've not seen the compiler code for this, like the code that makes C++ run, but just from knowing how functions work, right? So we look at this function here. Let's just look at the signature, right? So it's like we need one parameter of Ostream type, and here we need a parameter of bank account type, and we are giving extra functionality to the Ostream operators, okay? And what I've said a few minutes ago is C++, when this statement executes, there's some code that's like, oh, let's see if we can find functionality for Ostream, cout, and an account class. So it scans our code and it's like, oh, I found the candidate right here. So then we can conclude that cout is sent in as the first function parameter argument, and account is sent in as the second parameter argument. Behind the scenes, I'm pretty sure it generates that function call for us, although we don't see it, right? And then that's how this function works. And that's the only thing we can conclude, right? I mean, at some point, this function has to be called, and it's behind the scenes where we don't see. Hope that explains it.
Yeah, that doesn't make sense. I think that it had to be implicitly somehow. That it's kind of unclear, but that's a good explanation. Thank you.
Yep. Okay, so if we can do cout, can we do cin? Well, not yet, but we should, right? So again, before I go on to the code, what type is cin? Isstream, right here, Isstream type. And obviously we know this is bank account type. So for now, let's mute this. And now let's write another friend function. So start isStream reference operator for isStream reference, not cin, we name it n, just to differentiate. We do want a reference to account, but we cannot make it const because we know that cin modifies values. So we can make a reference of an account. And now we have the signature that we need, and we can go into our CPP and write some code here. Okay, I'm just going to write simple code here. The purpose here is just to show you that we can add overload functionality to the awstream and isStream operators. So I will create a local variable here, integer amount, and I will say cout enter amount. I'm not validating or anything, okay? And that's fine. I'm just showing you that we can enter amount, and then we have access to private data, so we can say account dot balance plus equal amount. We can do that. Nobody's stopping us from doing that, right? We have to return in. Why? That's the return value isStream, and we know by now that cin is in and in is isStream, right? So, however, we can also maintain some control by maybe asking them, do you want to deposit or withdraw? And then we could call deposit function and amount, right? But I'm not going to do that. I'm not going to type that code. For now, I'll just say account dot balance plus equal amount. So this one always adds to the amount. Our main goal here is, can we do cin account, and will it understand what we are saying? Hey, run this piece of code when I say cin account, and that account is of bank account type. So we come back here and we are okay. So let's give it a spin. Cin account, type isStream, type account, scans our code. Oh, I found the candidate. It's this function right here, isStream bank account, and the compiler, when we are running the program, will run this code, which is good, right? But the compiler, C++, right? So let's see. So cout account, cin account, cout account. Let's see what happens. Did I put a new line character at the end over here? Yeah, okay. So let's go ahead and run it. So enter amount. What happened here? Let me see here. I didn't call cin, right? And nobody corrected me. Y'all just let me fail. Okay, so let's come back here. Cin amount, right? Start cin amount. Well, that shouldn't matter. Oops. Run it. Enter amount 50. So now balance 150, right? And again, this is just to make sure that you know that you can do this, right? For the tic-tac-toe application, you will not in this homework, but eventually you'll have to overload the code, right? And from looking at main, you can see that once we start doing this, notice how main starts getting a lot smaller, right? Because we're abstracting the code into the class. So that's why I was not using getter and setter. So if you've been exposed to object-oriented program before, programming before, then you see like get balance, set balance, get bank balance, set bank balance, right? So those are getter and setter functions. But with overloading in C++, then we don't have to depend on that, right? Okay. Are we ever going to use this technique for something else other than CL? Yeah. Can we do friend for both? Well, one thing, you can do whatever you want in the function, but if you say you are overloading awstream, then make that be the main functionality, awstream, right? Obviously, in this stream, I'm forced to, I have to tell the user like what I need from them. Otherwise I'm gonna have frustrated users. So I have to use C out here. And honestly, like this guy is wrong, right? I should use in here. Again, nobody corrected me. I'll correct myself. Okay, so then we return in, right? So that code should still work. So let's. Yeah. So if you're overloading, like for example, the plus operator, then make it either concatenate or add. Don't make it like do multiplication, division, blah blah, and then no. Like you try to stick to what the original meaning of those symbols are, right? Otherwise, you confuse future developers, right? Okay, questions? Okay, one more. And we go to main. I should finish this pretty quickly. So if we have a bank account and then we have another bank account A1, and then what if I want to do bank account A2 equals to account plus A2. So notice again, I don't have that functionality yet, but it will be good if I get the balance from account and A1 and create a new object and get the lump sum of those two accounts balance into A2. That would be pretty cool, right? And if I'm showing you this, then that means that we can add that functionality. And yes, we should be able to. Okay. We add another friend. So friend, and what are we returning? Well, a bank account object, operator, the plus sign. We need a bank account const on the left side, account 1, account 2 on the right side, oops, right here. So again, if we go look at our code, when the compiler sees something like this, it'll be like, oh, has a developer written code to understand adding two bank account objects. So then it scans our code and it'll find this candidate and it'll be like, oh yeah, they did write some code. So we can assume that let me what do I do here? A1, A2, just so that hopefully it can match our signature, right? And hopefully students follow along better. A1 plus A2, right? So we have two bank account objects, and then we say A1. Okay, A1 is the first parameter. A2 is the second parameter. And then we can, before writing the code, we can be like, oh yeah, so this is a friend function. So I have access to each object's private data balance. So I can create a new bank account, get the balance from A1 and A2 and add them, and use that into my constructor for the new bank account object and return it. So that's what we are going to do. So we come here and we go here and we're like, okay, so let's do what I said. Bank account object, a new one. We know that we can use the constructor A1.balance plus A2.balance. So now we've created a new bank account object, account, with the balance of A1 and A2, and that's our new balance. So now we will simply say A, return this account. We jump back to main, and now the compiler should be able to understand our code, right? So we will say cout A3, just to get the balance of the value of A3, right? So now we want to see, well, what's the balance of A3? Is it 200 or what? Let's go ahead and run it. Run. Balance 200. So notice now we've added functionality. It's saying that I'm not using a count, but that's okay. Notice now we've added the functionality to be able to use the plus sign to add balances, right? And create a new account and then use that account. So questions? Let me see. Let me unlock the quiz.